Hello, everyone. I'm John Bell, Senior Consultant at Coringo. Thank you for joining us today to learn about using Elasticsearch with object storage. Before we begin, let's review a few housekeeping items. If you have any questions during the webinar, please type them into the question field. We'll try to answer all your questions as they come in. If we don't get to your question, we're happy to chat with you after the webinar. You can reach us by emailing info@coringo.com. We've also added several attachments that you can easily download from BrightTalk for more information. Our featured speaker today is Jamshid or Jam Afshar, and he's a senior software engineer here at Coringo. Welcome, Jam.
Thank you, John.
Why don't you go ahead and introduce yourself, Jam, and I'll follow up behind you.
Sure thing. Hello, I'm Jam, a developer at Coringo. I have worked on Swarm and Gateway. I'm especially interested in S3 compatibility and our usage of Elasticsearch, and also in containerization, Docker and Kubernetes.
Excellent. Thank you, Jam. Yeah, Jam is our go-to guy on the containerization and Kubernetes side of things, along with Elasticsearch. Again, I'm John Bell. I've been with Coringo for 9 years. And I'm a senior consultant here based in Austin, Texas. And I specialize in the design, implementation, and management of object storage solutions. Very good. So before we begin, let's provide all of you a quick overview of Coringo. Coringo was founded in 2005 to change the economics of storage by designing software from the ground up to solve issues associated with relentless data growth. Coringo's flagship product, Swarm, decouples data from applications and hardware, providing a foundation for continued data access and analysis that constantly evolves while guaranteeing data integrity. Today, Coringo software-defined solutions are used to preserve and provide access to rapidly scaling data sets across many industries by organizations such as NEP, BT Television, Disney Streaming Services, Real Salt Lake, Science and Technology Facilities Council, Argonne National Labs, Texas Tech University, the Department of Defense, the National Institute of Health, and hundreds more worldwide. And just a quick agenda for what we're going to cover today. We'll start off with a basic overview of object storage, specifically the concepts around data and metadata as they are handled within object storage. We'll dive further into the concepts behind what we call Swarm Search and the underpinnings of that being the Elasticsearch implementation that we integrate with. We'll go through some of the hardware requirements associated with deploying Swarm Search and any other infrastructure needs you may have to put in place to support that. And then Jam is going to walk us through a demonstration, and we'll handle any questions as they come in, and then leave some time for final QA and a wrap-up. And with that said, Jam, I'm going to go ahead and hand the reins to you and let you go through it.
Very good. Thank you, John. All right. So a lot of this is covered from the last webinar that we did, so I'll quickly review it. Metadata is stored on the object. These are special headers that get preserved with the object and that allow it to be searched. It has the same protection scheme as the object itself. So Swarm Search provides actionable insight, targeted analysis. You can classify your objects and search them by keywords. You can have extra information on objects that you can provide to users as descriptive content, and it's all contained within the storage system. The goal is to find the needle in a very large haystack, and that meshes well, we'll see with Elasticsearch. Our hardware, the Swarm Search hardware requirements are not very large. We're Red Hat CentOS 7, either physical or VM, and as I'll demonstrate, you can even launch it in Kubernetes. We recommend 3 servers as at a minimum and 5 for larger deployments, and going up from there. We have some customers who have a large number of objects, in the petabyte range, and where those are definitely needing more than 5, but they're not extreme, especially nowadays. 32 to 64 gigabytes of RAM, a terabyte of SSD, and you're good. The main things driving the size or the sizing requirements of your Elasticsearch cluster, of the Swarm Search cluster, is object count and the amount of custom metadata. It doesn't depend on the object size, since the objects are stored in Swarm. So this is the way it works. You have client applications that send their SESP commands to the Swarm cluster. Swarm or Gateway makes the search request to Elasticsearch and transmits the data back to the client applications. Okay, so that was just a review of what we had covered in the last webinar. So now let's do a screen share demo.
And Jan, while you get that set up, I'll add a little color to a couple of things that you pointed out. Going back to what Jan mentioned, one thing to bear in mind when you're looking at the nature of this solution is that Elasticsearch or Swarm Search itself is not where the metadata lives for object storage in our architecture. The data or content and the metadata associated with it is encapsulated as a single object that resides within Swarm storage. So when Jam is demonstrating this to you, bear in mind that the back-end engine that's handling this, which is Elasticsearch, is basically a cache of the metadata characteristics of the Swarm of the metadata that's associated with the objects that are stored in Swarm. So you could run into a scenario where, say, for example, for some reason you lost your entire Elasticsearch setup. And Jam, I think you're going to touch on that in some of the demo. And you can actually recover all of that very easily, even from the object store itself, because the metadata is always there. The Swarm Search piece is a cache of the metadata characteristics.
Correct. You can always, first, you can always refresh your feed. If, for example, your Elasticsearch cluster was lost, you can just refresh your feed in Swarm and it will populate. And as I'll demonstrate, you can make backups or snapshots of your index. Of course, you want to put it into a separate Swarm cluster because you can't recover from your Swarm cluster that lost Elasticsearch. But then you can recover that much more quickly than waiting for a refresh of the feed. All right, so this is the familiar Gateway portal. Hopefully you've seen this before from our last webinar. Now what we did first was just upload a bunch of animal pictures and videos. I've already uploaded the cats. Let's also do the others. And what we'll do is tag this data as it's going in. We do that by adding metadata. And these are dogs. We do the upload. It's completed quickly. And now let's do the others. The otters were the ones that were remaining.
We do otters because everybody does cats.
That's right, Jim.
So we try to be a little bit different.
of course, I do cats primarily for this one. I just love this little video. But the point of this was just to show a collection. Here is the collection. I've already created it. It is a saved search of all the objects that are tagged with cat. So you can see here that these are all returned. And it's updated live, so if you add an object later on with the cat metadata, it will appear in the search. And I'm showing this just so you have, oh, go ahead.
Yeah, a quick question. What is the typical format that's used for custom metadata when we want to tag objects with custom metadata? What's the format of the header?
We set this header, a header like this, X dash something and dash meta. The word meta has to appear in the header. And that's just a standard custom HTTP header, but it conforms to the HTTP standards. When you write the object into Swarm, you can also, of course, easily add metadata to an object after you have written it in without having to rewrite the object into Swarm.
Do we support like anything after meta, like X star,
yes.
meta star, for example? Yeah.
Right. The meta just has to appear in it, but it can be anywhere in there.
I see. Okay.
And of course you can have multiple. There's some standard metadata too, like the content type. So that'll be like an image GIF for just a picture, and a video content type of video for videos. And that's also something you can search for and find easily. And you can make collections for that. So you can show like, okay, all the videos regardless of the animal type. All right, so that's just to give you some background and to put some objects into Swarm so that we can demonstrate this. And here, so let's begin the demonstration. And by the way, these notes are accessible via our support portal. If you just search for this title, you'll be able to find it, or go to the URL you see here. Or if you don't have access, you can contact us via this webinar. We'll provide contact info at the end. So we started with Elasticsearch way early on, like back in its 0.x release, before it was really released. And very fortunately, and very much a relief, is that the project thrived, because a lot of open source projects don't. They either die on the vine or they get bought out and get closed. But fortunately, Elasticsearch has done really well, and so well that I'm continually surprised how often it turns up that our customers are using it just independently of Kuringo Swarm. So it used to be that it was kind of hard to get people on board with the idea of installing this Elasticsearch cluster to do their listings and searches, but now it's pretty standard. It's a pretty standard part of IT environments. Now what's exciting about this new Elasticsearch 7 release, and even the creator of Elasticsearch, Shay Bannon, points it out, is that it provides, it's always been able to snapshot, to make backups like any database, to make snapshots to object storage, to, for example, an S3 compatible system like Kuringo Swarm. But now you can mount the snapshot, a read-only copy of it, and search it, as if it was live. So I have links in here to this blog they have about it. It's very, very cool. They talk about things like that this is their entry into different tiers of search. The hot and cold tiers. So I highly recommend you checking that out, reading that blog.
And that it's worth making a point here that we always try to target here at Kuringo, what amounts to the best of breed tool or API or approach to solving problems such as this nature, finding a needle in a haystack. You have petabytes of data and millions or even billions of objects stored in a cluster. What is the best tool for the job to enumerate the contents of that cluster so that you can easily search, list, query, and get back a result set to the things that you're interested in quickly. And that's the power of using this along with object storage. It allows you to do that, and that's what JAM is showing you.
Exactly. Okay, so before the fun parts, let's get the hopefully boring, straightforward part out of the way, which is upgrading to this new Elasticsearch. Now, typically Elasticsearch upgrades have been a little bit painful, not because of any problems or anything, but just that it requires you to set up a new Elasticsearch cluster and to create a new search feed and wait for it to populate, then switch over to it. And that's very nice in some ways because it's a live upgrade. You don't have to disrupt your users. But the nice thing about the Elasticsearch 6 to 7 upgrade is that it's totally in place, and it can be done as a rolling upgrade. So it's done at once, or it's done quickly, and it's not disruptive.
All right.
Now we have all this documented, of course.
And for those of us who are customers on the call and are working with our Swarm Search implementation, the big win here is in prior versions, we always had to take the approach of installing, let's say you needed to upgrade, and you needed to upgrade from, say, Elasticsearch 2.3.3 to Elasticsearch 6, okay? The only way to do that would be to set up what we call a second search feed, wherein you're setting up a second cache of the metadata of the objects that resides in the storage cluster. But you install the newer version of Elasticsearch on that second cluster. It's basically a pivot to a new Elasticsearch. And the reason for that, Jam, as I recall, there are a lot of issues with things such as, handling schema incompatibilities and other things like that. I'm not as solid with the Elasticsearch piece as most people, but that was my understanding. And what's happened is that Elasticsearch themselves realized that this is very painful for their customer base to have to do this. So, and a lot of them have to be, up and running 24/7 on all the time. And as a result, from 6 to 7, you do not have to do this where you drop schemas, drop data. You can upgrade the actual operating binaries in place, and you can do it in a rolling fashion so that the Elasticsearch cluster is always available for list and query activity. And that's a huge win, and we've implemented that in the current version of the product, which is Swarm 12.
Right. We didn't have to do any schema changes on this upgrade from 6 to 7. Elasticsearch didn't make any deprecations that broke us. So that's been nice. It seems to have they've gotten more stable and we haven't changed our schema. So it's hopefully going to be smooth sailing from here on out. They're eventually going to come out with an Elasticsearch 8 in 2021, and it's looking like that will also be a simple upgrade. Okay, so just some background. The demo environment that I'm using is actually all running on my laptop. I'm using our Kuringo demo containers, which, if you want to check it out, are available in this KB here. And you can just search on our portal, just look for Kuringo demo containers, and you can see how to run it. It's just a few commands, assuming you already have like Docker for desktop or Docker on a Linux server installed. Okay. And also
we use that approach for a lot of our internal testing, don't we, Jam?
Yes, we do. It's a really great way to run very realistic little environments and to run tests across, because you want to be able to parallelize your tests and that makes it a lot easier to do. And you can also test across different versions very easily. And there was a webinar on containerization, and the demo containers were shown there, so please check that out too if you'd like to try this. So far, customers that have tried it have had very little problems getting it up and running on their laptops and servers. All right, so I have this environment already running. It's a little tweaked from the standard demo containers because it's running systemd, so that I can demonstrate our upgrade utility. Okay, so just if you're curious, this is what is running. There's like an LDAP server or a gateway. There's the 3 swarm nodes, and of course 2 Elasticsearch nodes. This uses a dedicated master node, the Elasticsearch leader. All right, so first let me copy. So this is currently, we'll go into the, there's a syslog container, and that just gets us into the network. And we can see that it is Elasticsearch 686. We can see that there are 2 nodes with the Elasticsearch leader being the master. Okay, let me first copy the RPMs that come with the Swarm 12 release into those 2 containers. There we go. Now let's go into the Elasticsearch container. If you're curious what's running, if you're a Linux type admin, you can just see it's a standard systemd with our the Java process running. It's a tiny Elasticsearch, just a gig. But if you have the memory, you can scale it up as much as you want. And if it's on Kubernetes, as we'll see, you can spread it out across multiple servers. Okay, so back to this upgrade process. First, we have to remove a plugin because the plugins aren't compatible across versions. So we'll remove it and then reinstall it at the end. So this is the Elasticsearch Repository S3 plugin. This is what allows it to make snapshots and restore from an S3 compatible object storage. Yes, 7. All right, now one thing that's very important, and it's tripped up our regular users, is you must install the Kuringo Elasticsearch RPM first and run it to do the upgrade of Elasticsearch. That's because it corrects some things, and it also simplifies your upgrade process because you don't have to install it separately. If you get the order mixed up, as we document, you'll get some errors, but it's easy to recover from that just by rerunning this upgrade script. Okay, I'm sorry, we already did that. This is what I wanted to run. So now we run our upgrade script. Just with -- upgrade. You can see it detects it. It understands that it's on ES6. It makes some corrections to some config files, and then it verifies you want to upgrade this node. So this is a live running node. It shuts down, or it disables shard allocation. That's an internal Elasticsearch thing so that it doesn't try to move shards around while it's going through this restart and upgrade process. And then it upgrades the config files for Elasticsearch 7. Something, if you're a Elasticsearch user, some things have changed, like the way master nodes are configured. Instead of like specifying the count, you just tell it a list of initial master nodes, and Elasticsearch now figures it all out for you. It's been kind of a pain point sometimes. So I'm glad to see that they changed that and are now handling it more carefully. So you see, it was successful. It finished upgrading it, and that's all there is to this node. So now we can go to the other node, the master node, and just repeat the process. Oh, sorry, I forgot to do. I wanted to add back in that repository S3 plugin. I need to make a quick little JVM setting so that it can be used. And now we restart the service. And when that's done, then we can move on to the Elasticsearch leader and do that.
And I would say to those in our audience, the main thing Jam is demonstrating here is that there are a lot of moving pieces to Elasticsearch. We've put a lot of effort into automating the upgrades like this that are associated with that, so that you don't have to figure this out on your own. We've put a lot of structure around this to make your life easier. So in future releases and future upgrades, it's going to be very, very simple to just kick off the associated set of scripts and upgrade your Elasticsearch in place.
Exactly. By the way, the script will install the Prometheus exporter plugin, which provides for some very useful Grafana dashboards to monitor your Elasticsearch. All right, and we're done. Let me just put the repository S3 plugin back on and tweak the JVM options and restart it. And of course, if you had, this is a small 2-node cluster, but if you have multiple, or if you have more nodes, you would just keep doing this across all the nodes. And of course, that's easily scripted like we do for some of our system tests. All right, so let's verify that we are on Elasticsearch, yep, 7.5.2. And we have the expected nodes with the leader being the master. Okay, so that was all that was required to upgrade from 6 to 7. You didn't have to create any extra search feeds or any new clusters. Just a quick note that you'll notice we're on 7.5.2, even though the latest Elasticsearch 7 release is 7.10. Unfortunately, there's a minor compatibility issue we have, but I'm sure we'll fix that soon in 2021. It's a compatibility in Gateway S3, and it was very unusual because Elasticsearch is at least pretty good about not breaking in their minor version releases. Like if you can talk to Elasticsearch 7.2, you should be able to talk to Elasticsearch 7.11. But they made a little change that tweaked us.
And to add some color to that, for those who may not be aware that are watching, our S3 API implementation has a dependency on Elasticsearch, and it uses Elasticsearch for the S3 associated list and query activity that S3 clients can issue against our on-premise S3 storage implementation. So, it's always very important that a lot of integration testing takes place between the gateway storage and Elasticsearch components. And that's what Jam was trying to relay there is, we tried to do a very good job, not only of aligning with S3 as it's published, but also making sure that the underlying components that support all that will present back to the S3 clients what they would expect.
Correct. Okay, so now I've exec'd into a container where I have a bunch of S3 clients. For example, S3 command. And we can see these are all the objects that we just saw in our lovely portal in the animals bucket.
And the neat trick to call out here, the content portal is using our native API, which we call SCSP, or Simple Content Storage Protocol. On this display here, JAM is using S3 calls to access the same data. And you will notice that they're basically accessed with the same domain and bucket location context, regardless of which avenue of access you're using. And the underlying architectural design feature associated with that is our emphasis on a unified namespace. This would not be possible without adherence to a unified namespace in Swarm storage.
Exactly, and that's very useful because there are, for example, a lot more S3 clients out there in the world than SCSP clients, but S3 does not have really any metadata search capability. So if you want to do that, you really have to use our SCSP API, for example. This here. Sorry.
Yep.
So you see, this is our search API. It's searching in the animals bucket. The format equals JSON tells Swarm that we want to get a listing, in other words, a search or a listing. And this is selecting the metadata that we want returned, very similar to the cats collection that we saw. It's just the same metadata. And we're saying which fields we want returned. In this case, just the name of the content type, as opposed to if you leave that off, you get back all the fields such as the size and when it was written, things like that. All right. So this is all pretty standard. Now, let's talk a little bit about Elasticsearch and how it does. It's a standard database, and you can make snapshots to and restore from object storage. That's become pretty common. I think almost all databases nowadays can talk to object storage, not just to file systems, which is very nice because you don't have to manage the file system then. You have it all just in your object storage. So let's show how to do that. We document this here, snapshot and restore of search data. So you can go through this in our documentation. Of course, this is a Elasticsearch Elasticsearch feature, and you can see it in Elasticsearch documents, docs 2. But it's simplified here in this demo. What we will do is create a bucket in which the snapshots will be placed. Oh, let me also start real quick. I always like to tail the gateway audit log because that is a nice simple view of what is going on with the gateway. So you can see it just took that put request where I created the snapshots bucket. This is the command that is run. So what this will do is initialize the repo in that ES snapshots bucket. and that's where Elasticsearch will write all its files that are a backup of its data. Oh, that's right. Let me change the key. Sorry, this was an old key that I copied and pasted. Oh, we can create that via the portal. Okay, let's create a S3 key. I'm going to simplify my typing and just have it be secret. All right, let me replace that. And by the way, that was a point I wanted to make is that this curl command, which is what is creating the repo, it's basically telling Elasticsearch, hey, you can write data using these credentials into Swarm S3. But there's a half dozen things that can go wrong. Either the endpoint, HTTP backup 42, which is the domain where that I've created in this cluster, it might not be accessible. The bucket might not exist. As we saw here, the access key or the secret key might be wrong. So, don't panic if you get an error because it's one of these things probably. And it's actually good because it's Elasticsearch actually verifying that it can talk to that endpoint and that it can create data in there. So now, and yay, okay, we got it. It's acknowledged. It's there. Elasticsearch now can now make snapshots into that bucket, and we can see that here because it did this listing request. It verified that it could create and delete some data in there. Yeah, so you can see these requests are all coming from Elasticsearch itself.
Right.
And hopefully this is making sense. I know it's a bit confusing because we're both using Elasticsearch and Swarm is storing data into Elasticsearch. And now with this backup process or snapshot process, Elasticsearch is storing data into Swarm.
It helps to visualize a snake eating its tail.
Exactly, yeah. It used to be with an older version of Elasticsearch, it didn't, for example, make listing requests in order to restore. So you actually could back up to Swarm and then have Elasticsearch restore from Swarm itself. That doesn't work anymore, but it was never a good idea anyway. Okay, so now what we're going to do is actually make a backup. Creating the repo just is that it can make snapshots. But now we want to create a snapshot. It's a point-in-time backup of the database, of the Elasticsearch database. And we can see it just chugging along there. It's just writing all the index data, all the objects that Elasticsearch has. And of course, with a really huge cluster, this would take a while and you wouldn't want to sit here and wait for it to complete. But this isn't very large. So you can see it's created it. It returns back a nice description of everything that was saved. These are all the indexes that got saved. We have a lot of metrics indices. The CS meter indices are related to gateways tracking of metering of bandwidth usage and of size usage by tenant and by domain and bucket. This is the one that we're really interested in, though, this index, because this is where the Swarm data is stored. The search feed data is stored. And I think I have some examples of that. That would come up later. I'm not going to show the restore because we don't want to restore back into itself. And what I really want to show is the mounting of this snapshot. And instead of doing a restore, which you can do, which brings back all the data back into another Elasticsearch cluster, I want to show off the new feature where it can actually read the data live without restoring it. It just mounts the snapshot and it has a read-only. It's effectively like a read-only copy of the data, and it's stateless. It's just all reading from Swarm itself, from the backup that is stored in that ES snapshots bucket. Okay, so first of all, a little bit of background. Containers, you can kind of think of them as tiny VMs, of tiny virtual machines. They're really just Linux processes. And Kubernetes is a container orchestration system for automating application deployment, scaling, and management. And I'm showing this because I want to show you how easy it is to deploy Elasticsearch to Kubernetes using the new Elastic Cloud Kubernetes operator. Okay, so there are dozens of ways to run Kubernetes on either your laptop or home machines or on big Linux servers. Probably the easiest way to run it on your laptop, Windows or Mac OS, is to install Docker for Desktop. That's what I'm doing here. It effectively lets you run like a little Kubernetes cluster on your laptop. If you want to install it on real Linux servers, I recommend the Catch-up utility. What this does is it's just a simple script or a simple little utility that bootstraps Kubernetes from your, it bootstraps Kubernetes at the Rancher distribution of it. It's a simple and slim Kubernetes distribution called K3S. From the folks at Rancher, an open source company that was recently acquired by SUSE Linux. Anyway, I'm not going to demo that here, but I've done it, and it's really just a couple of commands. It's really nice. Okay, so and there's a little cheat sheet on Kubernetes. That's very handy. So now, a Kubernetes operator, what is that? So that is an application-specific controller that extends Kubernetes to manage a complex application such as Elasticsearch. So this is something that Elasticsearch has developed, this operator, because it's a lot easier than, you can of course write your own YAML for deploying Elasticsearch, but the operator takes care of a lot of things for you. You don't have to configure, everything individually. And they also do a lot of operational, I haven't used it really, the version upgrade stuff in the operator, but it's supposed to be very nice and takes care of a lot of things that you would have to be sitting there on the command line doing or writing a bunch of YAML or scripts to do.
And Jam, I don't mean to push you too hard, but we've got a time check here, so.
Oh, sorry, okay. I've already installed the operator. It's really just this command. I think I'm already monitoring it. If you want to monitor the command. All right, first of all, there are no pods currently in use, good. And this is it. I'm going to, all right, so what happens is that kubectl apply, it takes this YAML, which describes what we want. That's really what Kubernetes is you tell it, okay, this YAML describes the services and configuration options that I want, and I want you to deploy it and meet this specification. So it does, it takes a little while. Oh, not that long. It's already up and running. If you want to, so sorry, what I did was I launched 2 nodes of Elasticsearch 7.10.1. I have some settings in there. I asked it to install the repository S3 plugin because I wanted to talk to our S3 backups. If you want to see logs for Elasticsearch, for the Elasticsearch nodes, that's how you do it. It's just JSON format, but it's just standard Elasticsearch logs. Now, to access that, this Elasticsearch, we run that command so that we can access it through localhost. You can see it's Elasticsearch 7.10.1. This is totally unrelated from the Elasticsearch that is being used by Swarm. And you can see that it has the repository S3 plugin. And we can verify that, yes, this is a fully functioning Elasticsearch cluster. I've written an index into it, and I can search. See, I get back my foobar doc. Okay, so now this feature that we're demonstrating, the searchable snapshots, requires a trial license, and it's officially still in beta, but it's easy to get that. All right, so now I'm going to create pretty much the same snapshot repo, and I'm going to get the error about the access key, so let me copy that. All right, got the new one. There we go. Okay. So now let's verify what what snapshots we have. A little bit better output. Yep, there it is. That's the one. So remember, this is going through the new Elasticsearch. It's because all the information is stored in our Swarm bucket, it's able to access it. Let's just verify the status of it. Oh yeah, it's got lots of stuff. Okay, so this is the magic new feature that it's mounting a snapshot as opposed to restoring it. There we go. Now I named it the index offline dash with that prefix, just to keep things nice and separate. And now we're going to search that Elasticsearch cluster for one of the objects that we had, or for the objects that we had in here. And there we go. These are all the same objects that we had inside of the real Elasticsearch that's associated, 7.5.2 Elasticsearch associated with Swarm.
Very neat.
And
Very neat.
Yeah, I guess I could have been tailing this, but you will see here, these are all the requests that the 7.10 Kubernetes Elasticsearch cluster is making. It just queries that bucket, it finds all its little objects that are in there, and it's able to make queries against that and use that almost exactly as if it were on disk. Now, so what's great about this is that this is all stateless. The Kubernetes Elasticsearch cluster that I created, there's no data permanently stored there. It might cache some things, but there's nothing permanent about it. I can freely blow it away. So the use case for this, and the Elasticsearch blog talks about this, is keeping years worth of indices that you wouldn't want to keep running in an Elasticsearch cluster because that's expensive. You want to keep your Elasticsearch cluster running, able to perform fast queries on recent things. But if you ever want to go back and look at old data that you don't mind with the queries being a little slower, you just point it to your S3 backup of Elasticsearch indices, and you're able to query those. Yeah, so that's what searchable snapshots are all about.
And we say, that that it may be slower. But the thing to bear in mind here is that sitting behind that S3 endpoint that Jam just described is what amounts to the scale-up, scale-out architecture of Swarm itself. And the performance of that is going to scale up and out as you add more resources to that cluster. So it may not be as fast as local SSDs, for example, for storing the shard information. But it can still be pretty quick, especially if it's very local. If you're going over 10 gig Ethernet or even faster, if you have some very good performing gateways and so on, and a robust Swarm cluster for storage sitting behind it, this could easily meet your SLA for turnaround time on queries if necessary.
Definitely. And I was noticing that Elasticsearch is working on more caching of the data. So we may be seeing more in that respect coming out, where it caches the data, it reads from our object storage, and is able to make it much more like a live index.
Mm-hmm.
And then the only one other thing I wanted to mention is just that this example of not only using S3 or using object storage for backing up things, but actually using it for searching and for doing live queries. This example from Elasticsearch is hopefully it's a trend that seems to be happening. The other system that I saw using it is Loki, which is a log management system from Grafana, the dashboard folks. And this lets you, it's a multi-tenant log aggregation system. So of course, when you're dealing with logging, that's tons and tons of data that you can't really afford to keep live, and you want to store it in object storage. But they've come out this year with features so that you can actually store everything in object storage and access it in queries directly, and without the separate step of going through a full restore process. Where you bring all the data back live. It just stays in cold object storage and is used directly from there. And it's still very useful. So I really like that kind of thing, of making your object storage serve your live needs, not just be a place where you dump things and don't really use it again unless it's an emergency.
Yeah, and I agree, Jim. That's a trend we're seeing in a lot of things where people don't want to have to waste a lot of time moving things around. They just want to be able to use it and manipulate it straight up from where it already sits. And in many ways, it saves a lot of time.
Yeah. Whenever you don't have to deal with that hassle of doing the restore, it definitely saves time. Okay, so that concludes
very good.
the
I
demo,
imagine that's what you have for us today.
Yep, very good, because I only have that much time, I guess.
Yeah. Well, outstanding, Jam. We appreciate all of that. That was very informative. So again, I would like to thank everybody for joining us today, and thank you, Jam, for that presentation. It's excellent. And for those of you on the call, to keep up with Caringo, be sure to follow us on Twitter, LinkedIn, or Facebook. If you have additional questions or would like to schedule a custom demo, please email us at info@caringo.com. And I'd also like to take the opportunity now to invite you to next month's Tech Tuesday, where Ryan Meek, who is our Caringo Principal Solutions Architect, will be back in the host seat for the presentation for building a complete on-premise object storage solution. And that webinar is going to feature Chris Keogh, and he is the head of infrastructure engineering at Fujifilm, and also Jose Marcus, who is a sales engineer here at Caringo. And we look forward to having you then. That said, thank you all for attending. We hope you go about and have a wonderful day today. Take care. Goodbye.